So yesterday we had left off on example 3. So add yourself a blank page and draw yourself 2 little triangles and write down the words angles of elevation and depression. We are going to start talking about applications of right triangle trigonometry. Right triangle trig was invented, discovered, used because it is so absolutely necessary in our lives. From building things, from measuring things, it is just extremely useful. So there are lots of applications for it. 2 of the most common are angles of elevation and depression. So let's talk first about angle of depression. So an angle of depression, you are above what you are looking at. So if this little guy flying his airplane is looking straight forward, the angle of depression is how much he needs to drop his eyes in order to see the dog's house there on the ground. Okay, so there's a little dog house. If he wants to see the little dog house, that is the angle measure that he has to drop his head in order for him to see the doghouse. Now, you may recall back in geometry class. In geometry class, if you had 2 lines that were parallel and you had a transversal, there was a rule that these alternate interior angles were congruent. Okay, so I'm throwing it back to geometry class for a minute. If you have parallel lines and a transversal, alternate interior angles are congruent. So we can also say that this angle measure will also always match. Okay, so if we need to get that angle inside of our triangle, it does not go up here. It actually would go down there because of alternate interior angles. Okay, now let's talk about the dog over here. Now, an angle of elevation is the angle it takes for you to look up at something taller. So you are looking at something above you. You are looking at something above you. So if this dog sees a squirrel at the top of the tree and he has to lift his eyes up to see the squirrel that's at the top of the tree, that angle measure that he lifts his eyes from the ground, whatever angle he needs to lift his eyes up to look at the top of the tree, that is the angle I am talking about. So let me say that one more time. An angle of depression is when you are above something and you look down to it. And you have to watch where the placement goes inside the triangle. An angle of elevation, you have to elevate your head to look up at something that is taller than you, whether it is a tree, a building, whatever it happens to be, an airplane flying in the sky. So that is the difference between those 2 things and the placement of those 2 things. It's very important that you know the difference, okay? Now, that being said, let's go ahead and look at the example that we left off in the 7-1 notes yesterday. So if you look, I'm talking about this example, okay? So it says that a competitor in a hiking competition must climb up the inclined course as shown to reach the finish line. Determine the distance in feet that the competitor must hike to reach the finish line. Now it says that the starting spot is 1 mile from the finish spot is 1 mile out from the base of the mountain. So please mark that as 1 mile. And we know the incline of the mountain at this hiking competition is a 48-degree angle of elevation. Okay, so he is 1 mile out from the base when he starts. The angle of elevation is 48 degrees, and we want to know what is the distance in feet that the competitor must hike to reach the finish line. So our X should go there. So the actual spot, think about the actual spot that he is hiking. Now, it says determine the distance in feet. So if your measurement doesn't match, we're going to convert it. So let's make this 5,280 feet. And if there's ever any conversion that you don't know, feel free to use Google and look that up. But it's a nice fact to know that 1 mile is 5,280 feet. So now we have a triangle, and think about how we did the problems at the beginning of 5-1. We would always label what the sides are that were given. This angle here, because of where it is sitting, this is the adjacent, and this is the hypotenuse. So let's always take a moment to label what we have. Yesterday, we learned about SOHCAHTOA. Of our 3 original trig functions, sine, cosine, and tangent, which one uses adjacent and hypotenuse? Which one uses adjacent and hypotenuse? The ca, right? The cosine. Is that so? So let's write that formula down. We know that the cosine of theta is adjacent over hypotenuse. And let's fill in the blanks. Okay, we know that the cosine of 48 degrees is adjacent over hypotenuse. And you might recall yesterday we had a problem that ended up being similar to this. Anything that is in our denominator needs to cross over. So in this case, we have an x in our denominator. So let's take that x, because that's division, on the opposite side of the equation, it would be multiplication, and let's cross that over. So we know that the cosine of 48 degrees times x will be 5,280. So we know that x would be 5,280 divided by the cosine of 48. So that's what we want to enter into our calculator. Now, if it doesn't mention it, for my purposes, if we are looking for degrees, rounded to the nearest degree. If we are looking for lengths, rounded to the nearest tenth. Now, if they specify something different in the instructions, do that. They did not specify. So we're going to put in 5,280. We're going to hit divided by the cosine of 48. Please remember, you have to be in degree mode. When rounded to the nearest tenth, that is 7,890.8 feet. Now, for real life applications like this, please always get in the habit of putting your units down. And please make sure that you round, if they didn't specify, I want it to the nearest tenth. This is our hypotenuse. That should be a longer length than what we have in for one of our legs. So the fact we got a number bigger than 5,280 is a good thing. Yes.
How do I put my calculator in degrees?
It is right there. It says, if that says D, it's in degrees, but I'm not sure. We'll have to look afterwards. Any questions about example 4? Okay. Now, one thing you might have noticed is that everything we did yesterday, we were always looking for the side, but never the angle. For us to look for the angle, we are going to use the inverse trig functions, and that is the only time that we hit the second button on our calculator. We have to hit the second button, then the sine, the cosine, or the tangent button, okay? So please know if the angle is missing, you want to see this -1 notation. And so if you look on our calculators, if you look at this giant calculator at the front of the room, that little -1 notation, that means we're looking for an angle measure. So if you see that little -1 notation, it has nothing to do with a power. It is just a notation. It is telling us we are missing an angle. Some older textbooks, some European textbooks, if you go online, depending on where the person is from, you might also see the little arc in front of the word sine, cosine, and tangent. So it just says arc. So arc sine, arc cosine, arc tangent. That is just another way for saying I am looking for the angle. Think of an arc. It's an angle, you know. So anyway, those are just notations. So if we are missing a, just so make yourself a note that if you have the little -1 notation, or if I write the little -1 notation, or if I write arc in front, that is the only time we hit the second button on our calculator, and that is the only time that we are looking for an angle measure. So remember, this is saying this is an angle. That is the only time we use that notation. And this is just saying in your calculator, you're going to put that fraction. So if we are looking for an angle measure and we know the opposite and the hypotenuse, we hit second sign, we put in that fraction that makes that opposite over hypotenuse, we hit equals, it's going to give us an angle measure. Be careful. If your calculator's in degree mode, it's going to pop out a degree. If your calculator's in radian modes, it's going to pop out a radian. They're very different things as far as measurements go. So that's just a notational thing that I wanted you to see. We're going to explore more about inverse trig functions later on. For now, it's just inside a triangle. We're looking for an angle. What do? You're going to hit the second button. First is the main takeaway. Okay. So here's one where we're missing an angle. So I want to show you how to set that up. We're pretty much going to do exactly what we did before. Here's our hypotenuse. Here's the opposite. Which one of our trig function does that? That would be our sine. So it's exactly initially the very first setup. So we're going to write down the formula. The sine of theta is opposite over hypotenuse. And we're going to plop in what we know. So the sine of theta is opposite 12 over hypotenuse 15.7. Now, for the very first time, we are missing the angle measure. Before, every single thing we'd done before this, we knew the angle measure. To find the angle measure, it becomes an inverse sine operation on the other side. And you have to do this in a calculator. We don't have at this time any information on how to find it otherwise, okay? So you would just put that into the calculator exactly like what you see. To get that little -1 notation to pop up on the calculator, we are going to hit the second button, or in some calculators, an inverse button. Then we are going to hit the sign, okay? So it's just, I would practice on your calculator, make sure that you know how to do it. For angle measure, it says to round to the nearest degree, so that is what I'm going to use most of the time. When rounded to the nearest degree, you get 50 degrees. So if you have a calculator and if you want to check, are you getting the calculator to do that? That would be the main thing here. You have to hit the second sign button for that little -1 notation to come up. You never hit the second sign before the sign for any other reason, only if an angle measure is what you are finding. Okay, if you're finding a length, you're never going to do this. It's only if you're missing the angle measure that you'll ever hit the second button. So I just want to make sure that that's very clear. Okay, so now let's do one more. This is really about an angle of depression. So let's talk about a real world example, example 6. It says a person on an airplane looks down at a point on the ground at an angle of depression of 15 degrees. The plane is flying at an altitude of 10,000 feet. How far is the person from the point on the ground to the nearest foot? Okay. So let's set up the situation. We've got that airplane flying up above. And if it wants to look down to a person on the ground, we have to lower our head. So let's say somebody is in one of those windows. They see a person on the ground. They have to drop their head 15 degrees to see the person on the ground. So we're talking, there's a person standing right here. Okay. Now it says the plane is flying at an altitude of 10,000 feet. So that is your vertical height, 10,000 feet. So that goes there. How far is the person from the point on the ground to the nearest foot? So they want to know how far is the person on the ground from the plane. So we are talking the fact that we are looking for the hypotenuse. Now you'll notice our angle is not in the triangle. Don't expect it to be. These always add up to 90. So you are welcome to put 75 up here if you want an angle in your triangle. But because of alternate interior angles are congruent along a transversal, you could also put the 15 degrees down there. I don't care which technique you use. Let's talk about if we use the 75. If we use the 75, this is the adjacent, this is the hypotenuse, and we would say that the cosine of 75 degrees is adjacent over hypotenuse. That's a correct setup. So if you are a person that did this problem and you did cosine of 75 degrees is 10,000 over x, bam, you're going to get the right answer. But let's say your neighbor decided to use the alternate interior angles are congruent rule and put the 15 down at the bottom. For the 15, this is the opposite. This is the hypotenuse. You can also set up the 75 the sine of 15 degrees is opposite over hypotenuse. Now, why does that always work? Well, the sine and the cosine are cofunctions, sine and cosine. The complements, you remember back in geometry, complements add up to 90 degrees. If two angles add up to 90 degrees, the sine of one will always be the cosine of the other, or vice versa. So it just so happens that always happens. And that's because it fills the right triangle perfectly if those two add up to 90 degrees. So if you decided to do the top one, cosine of 75 equals 10,000, or if you decided to do the sine of 15 equals 10,000 over x, they're both right. You just pick, it doesn't matter. Because the one in blue there, the sine of 15 is in the bottom, let's continue with that one, okay? So I would get that x is 10,000 over the sine of 15. Well, why does that happen? Because this one would cross over and then this one would cross over. So it's almost like they switch spots. So if you do the top one using the cosine of 75, or if you do the bottom one using the sine of 15, you're going to get the same exact answer. Just make sure that your calculator is in degree modes. And when rounded to the nearest foot, because I'm following the instructions, I get 38,637 feet. So it is 38,637 feet away from the plane to the person on the ground. It is our hypotenuse. It should be the longest side. That 15 degrees makes it so that they're pretty far away from one another. So that is example 6. Do we have any questions about example 6? So feel free to have used this one or this one. They are both correct. So there are times where we can get multiple ways to solve the same problem. Okay, let's do this one. Now this one is a pretty difficult problem. Let's read it and then let's talk about it. It says an angle of elevation from a hiker to the top of the mountain is 25 degrees. So there's a person hiking. My daughter loves to hike, so this little person, that's my daughter. Her name's Marissa. Marissa's hiking, and she sees a mountain, and she looks to the top of it, and she raises her head 25 degrees in order to see the top of the mountain. Okay, she hikes in 1,000 feet. This time, to lift her head to see the top of the mountain, she has to lift it a little higher. Think about if you are far away from a tree. To see the top of the tree, you don't have to lift your head very much. But think about if you're pretty close to the tree, think about how much you have to lift your head in order to get to the top of the tree. A lot more, okay? So that's kind of how that works. And then it says, how tall is the mountain? You cannot solve this problem without doing the following. And so we are going to have problems like this where we have kind of two triangles nested inside of each other. The best way to solve this problem, let's pull the triangles apart. So let's look at our first triangle. That's going to be the biggest one. And then this one's going to be the steeper one. And don't expect my triangles to be to scale, but this will at least get you going here. Okay. So we need to label something. I'm going to label that with a Y. Okay, so let's go here. So our first triangle is this entire distance, 1,000 plus Y. And then there's an X. And then this was 25 degrees. Okay. So that's our first triangle. Now we walked in 1,000 feet. And so now we are this triangle. So that's just going to be Y, X, and 28 degrees. So you always want to rip the two triangles apart. That's your first step. After you've drawn the situation, pull the two triangles apart. For both of these situations, we have an opposite and an adjacent. An opposite and an adjacent. Opposite and adjacent is a tangent. So what do we do with tangents? Well, let's set up our tangent equation for each triangle. So the tangent of 25 degrees is opposite over adjacent. The tangent of 28 degrees is opposite over adjacent. Now you might recall back in the day, back in Algebra 2, probably even Algebra 1, you did systems of linear equations. We even did some systems a few months ago. In order to solve a system of equations, we have to take the two equations and somehow put them together. So let's use a calculator and let's find out what is the tangent of 25 and what is the tangent of 28. We're going to go to 4 decimal places. The tangent of 25 is the decimal 0.4663. I'm sorry, yeah, that's 1,000, okay. The tangent of 28 is 0.5317. Now, I'm just putting those numbers in because I don't want you to get confused. That's just a number. Okay. And then I am going to cross multiply for each of those values so that I can get what X is equal to. So I get 0.4663 times 1,000 plus Y is equal to X. I just cross multiply. And here I get 0.5317Y is equal to X. Now, both of those equations are related to x. So the rule of thumb, because of substitution, I know that x is equal to 0.5317y, so I can just put it right there. And then the only variable in my equation will be y. So let's take this information and let's put it right there, okay? Now I will tell you, these are some of the hardest types of problems we're going to do for basic triangle trig. So if you see and you're looking like, oh, that's a weird problem, it is, okay? Okay, so we get 0.4663 times 1,000 plus y is equal to 0.5317y. Now, if I just gave you this equation and nothing else, and I said solve for y, I hope that you can do that. It's just an equation with y's in it. Get the y's to one side, the numbers to the other side, and do your thing. Well, this y is locked in a parenthesis, so let's distribute so that we can get it to look a little nicer, okay? So let's distribute. If we distribute on the left side, we get 466.3 plus 0.4663y equals 0.5317y. Now that's a pretty nice equation. This y right here just needs to subtract to the other side. So if we subtract 0.5317 minus 0.4663, we get the following: 466.3 equals 0.0654y. So now we're even closer to finding out what y is. Now, if something is multiplied by your variable and you need to get rid of it, we use the opposite, division. So let's divide off the 0.0654. So y is equal to 466.3 divided by 0.0654, and that is 7,130. Okay. Now here's something very nice. We know that x is always y times 0.5317. We had a nice equation for y. So let's just plug that y value in right here. And then we got x. So x is 0.5317 times 7,130. And we get 3,791 feet, which is the height of the mountain, which was what we were looking for. So there is our answer. Now that is the hardest type of these problems that we're ever going to do. We're going to set up two triangles. Most of the time you're going to use a tangent. You're going to get two equations. You're going to put the two equations together, and that will allow us to solve for one variable or the other. We were looking for x. We were looking for the height of the mountain. We found x was 3,791 feet. Please label it with the units that are appropriate. Those are hard, I know that, but they do follow that same pattern again and again and again. Okay. So that's a crazy angle of elevation one. Now we're done with those notes, and there's not a spot to turn in notes. You're going to just turn it in when you turn in your homework in the homework spot. You are ready now to do the word problems, okay? But we need to talk about a project that is coming up. So now if you could go into your Google Classroom and please find the 7-1 project paper and put that now into Notability or Colanote or wherever you're writing. Could you please open this paper up, and we're going to talk about the project that's coming up. Now let's talk about the project. The project is 50 points total. You are going to pick any of the 20 problems that follow. There are actually 24, I believe, or 25 of them. You're going to pick 20. You are going to complete them, and they are graded like a quiz for correction. They have to be correct to get the point. There are extra, so if you do, there are 26 of them. If you do all 26, any extra that you get correct, you could get 6 bonus points. So you could get some bonus. And then you're going to have one problem out of all 26. You are going to be assigned one problem that you have to depict on a digital poster. You're going to submit one page, either a PDF of one page or a JPEG of one page of your poster that is worth 30 points. 5 points, did you get it done on time? Was it turned in? Were you using your time wisely? 5 points, did you take the time to make your graphics clear and concise? The required elements are listed here. That's 10 points. Attractiveness, did you take the time to do it? And originality, okay? And you can read the rubric right here, but it's worth 30 points. And an example of a digital poster, a sample, is given on the very last page. It has all the elements in there. You can draw some stuff. You can use some artwork online. Feel free. The answers are given to you because remember, they're graded for correctness. So I need to see the setup of every problem, and I want you to be able to check your work as you go because it's graded like a quiz, okay? So at this time, I am going to have you pick your problem, and but while we're picking problems and all that stuff, you can start looking at these problems. You can pick any 20 to do. You have this homework also you should be working on this time, okay? So that is that. Let me go around and you can pick your problem.